Welcome to qnawire.
Quick sketch of the graph that we are given, and in this problem we're just going to answer some questions about the graph. So in part A we're trying to find on what open intervals is our function or our graph increasing. So I have some of the important points here in red, and this first red point is actually the minimum or a local minimum of this graph, and we know that for f to be increasing it needs to be going up. And at a minimum value, that's actually where we go from increasing to decreasing. If we are actually going from increasing to decreasing, we could have a minimum value that's just like this, and then the graph just stops. But in this case, we're not just stopping, we're keeping going. So this is a minimum value, local minimum. And whenever you have a local minimum value, that means that we're going from increasing to decreasing, as long as it's like a curve, or sorry, decreasing to increasing. So we're increasing from 1 to this maximum here, from 1 to 3. So our interval for increasing for this first part that we're increasing is from 1 to 3. So you can say from 1 to 3. And I know that since our minimum value is when we go from decreasing to increasing, and this local maximum value is when we go from increasing to decreasing. So we're increasing in this interval between our minimum and our maximum. And then the next part that or the next interval in which we're increasing is going to be this part of our graph over here after we get to this point, and then there's just a jump that seems to be going up, and then our graph just stops. So in this part of our graph, from this point to this point, we're still increasing throughout this whole range of values. So you can say that the other interval is from 4 to 6. And now for part B, we're going to try and figure out on what interval our function is decreasing. So decreasing is going to be this part of our graph here, since we're going down, and it's going to stop at this local minimum, since we know when we get to this minimum we're going to be increasing afterwards. And then we're going to also have this interval over here after this maximum down to this point here at 4, 1. And then after the point 4, 1, you can see that our graph is increasing. So that's the last interval of decreasing. So we have this first one from 0 to 1. And then we have the second interval from 3 to 4. And now, write that in black. For part C, we're trying to figure out where we are concave upward. So it might be a little bit hard to tell on the graph that I drew, but if you looked at the original graph, it was pretty obvious that this point at 2, 3 right here is an inflection point, and it's where we're going from concave up to concave down. So we're going to have our graph be concave up from 0 to this point at 2, since this is our inflection point. And then past this, we're concave down until we get to this point. And then at this point, we do a jump, and we're still actually concave down past this point. It kind of just goes down here and then jumps up. It's not a very smooth curve, so there's no point where we're going from concave down to concave up. So the only place on our graph where we're actually concave up is this first interval from 0 to 2. And for part D, we're going to try and figure out where our graph is concave down. So as I said earlier, this point at 2, 3 is our inflection point, and so we're going from concave up to concave down at this point. And from 2 to 4, we're still concave down, and then from 4 to 6, we're also concave down. So our intervals are going to be from 2 to 4, or this part of our graph here, and then also from 4 to 6. So our two intervals from 2 to 4 and from 4 to 6. And then the last thing that we're going to find on our graph is the actual inflection points of our graph. And so as I stated earlier, this point is actually right here at 2 comma 3. And the reason I can tell that it's an inflection point is because we're going from being concave up to concave down. Inflection points are points in which we're either going from concave up to concave down or from concave down to concave up. So this point here at 2, 3 is the only point on our graph that actually does this. At this point 4, 1, we're going from concave down to concave down again. So it's not an inflection point. So our only inflection point is at this point 2 comma 3.